I've had a falling out with my drone kit. It's very delicate and I've ripped off the USB connector. It's also got heat issues when driving my hoverboard motor. So goodbye and hello to this bit of VESC hardware. So VESC normally make hardware for electric skateboards and electric scooters, but I want to use it in more of a sort of robot scenario. So here's what I've got linked up. I've got an SD link to program it, USB to serial to get some debug from it, and some like 3 lots of Hall sensors which are part of the hoverboard motor. This FlipSky Mini is a clone, very similar to the VESC 4.12, very capable, 50 amps continuous and up to 60 volts. It uses a DRV8302. So this is one board in the VESC ecosystem. It can do about 1 or 2 kilowatts of power. There are some boards that I think can do like 8 or 10 kilowatts. I'll talk a bit more about them at the end of the video. What's really exciting really is that we can put custom Arduino firmware onto this now. So it's great for robotics projects. In literally 30 lines of code, you can get your robotics projects working and spinning powerful brushless DC motors using the SimpleFOC library. I'm in closed loop velocity mode. The servo tester is used to adjust the velocity. You can take it up to about 50 radians per second. At the moment, my power supply is at 32 volts and I'm drawing about 1 amp at full speed. So it's still very early days with me testing on this board. Got Hall sensors working on port 2. That means encoders should work there as well. Port 3 we've got serial, but there's options for I2C and SPI on that port as well. I haven't got the USB working yet and I'd really like to do that, so that would free up port 3 for things like a balance MPU 6050 chip. Be aware that if you do replace your firmware with something like this, then the board won't show up in the VESC tool because there's no USB bootloader. You'll have to reinstall the USB bootloader first. And now I've uploaded another sketch, but this time in angle mode. So when I turn the knob, the motor will change its angular position. Once I've done a bit more testing, I plan to submit a board to STM32 and that will mean you'll be able to select this board from Arduino IDE and Platform IO. Until then, you'll have to copy some ugly header files into your project in order to use it. So I don't want to spend more than a minute on the code really. I'm using SimpleFOC, so you configure sensors, motor and driver. I'm using 6PWM version of the driver here. It's a little bit of code to read the duty on this servo. Like here, this is where we're kind of configuring the sensor, the driver and the motor, a few PID parameters, a few limits, that sort of thing, setting velocity or angle control, and then just a little bit in the loop that does the FOC and reads the servo. To get this working, I basically started from using this generic STM32F405 and then sort of overridden a couple of things. So I've got a system clock config for it, and at the bottom I've overridden some of the pin maps here because some of them weren't on the correct timer 1 channels, and then I've broken out and defined what all the pins are to make it a little easier to use. Well, that's about it really. I will put a link to this in my repo. So these are the standard VESC boards. You can see there's a 70 volt 300 amp one here. These are used for things like e-scooters and skateboards. VESC is done by Benjamin Vedder. His boards have been cloned quite a bit, like these ones for instance. So if you buy a clone, then it's probably worth giving him a donation. And then there's a whole bunch of other boards, like open source boards that people have built themselves that you can get VESC onto, and those are sort of also, because they use very similar pin out, they're probably fairly easy to get working in Arduino and SimpleFOC. I think for my ongoing project, my balanced chair thing, I think I'm going to buy this dual board from FlipSky. It's essentially like a VESC 4.1.2. There's two separate STM32F405s on it, and the only thing connecting these two sides is a CAN bus really. So hopefully that will unlock my balance chair project. Thanks.